Hello and welcome to another episode of Nothing Ventured with me, Aarish Shah. Today in the studio with me, I had Simon Kohl. Simon is the founder of Latent Labs, a London and San Francisco-based startup using generative models for computational protein design. Simon studied physics at the Karlsruhe Institute of Technology before pivoting to machine learning for medical imaging during his PhD. His work led to an internship at DeepMind, where he later joined the AlphaFold 1 and AlphaFold 2 teams, developing key uncertainty metrics for protein structure predictions. He then co-led DeepMind's generative protein design efforts, setting up a wet lab to validate AI-designed proteins. Seeing a gap in bringing this tech to market, he founded Latent Labs. Now, 1.5 years in, Latent Labs has just raised a $50 million Series A led by Sofinova Partners and Radical Ventures to advance AI-driven biotech. In today's episode, we talk about generative modeling and protein modeling, making biology programmable, transforming science, building AlphaFold 2 within Google DeepMind, and moving biology from the lab onto the computer.
London and San Francisco really are hotbeds at that intersection of biology and machine learning.
How building frontier models to improve the process of drug discovery is the future, and why the UK and Europe are powerhouses for scientific progress.
I think that's definitely true for the sort of hard natural sciences and beyond, right? But I guess that's what we're talking about.
How the way you present an idea matters, be agile but maintain your conviction, and when fundraising, how nimbleness should not translate to indecision.
Because you're going to have to make a lot of decisions very quickly, and if you make them too slowly or are too indecisive and maybe even, go around asking your entire network, you'll basically sample answers and you'll sample the entire space. You'll get every possible answer.
Building teams in multiple locations is critical if you want to access the best talent, and Simon's controversial conviction.
In the industry overall, it feels like an accepted wisdom that platform companies, especially computational platform companies, can't really work and scale and grow very much.
Let's get straight into it. Hey guys, whilst I've got you for a minute, I thought I'd reintroduce myself. My name's Aarish. I am the host of Nothing Ventured, the podcast where I talk to the people behind the stories that make the venture ecosystem go round. I'm also the founder of Emerge One, a consultancy that provides fractional CFO support to venture-backed tech startups. If you like the podcast, we'd really appreciate it if you like, rate, and subscribe wherever you listen. And of course, if there's anything you want to talk to me about, whether that's a guest that we've had on or someone that you really love to see on the show, don't hesitate to get in touch with me via LinkedIn or X. I call it Twitter. Right, let's get straight into it. Simon, really great to have you in the studio with me. Thank you so much for joining.
Thank you very much, Aarish, for having me.
Okay, we're going to get into quite a lot of detail, and there's a lot to unpack given what's been going on over the last few weeks with you, Latent Labs, and what you've been doing. But you were a part of the core team at DeepMind, which was working on AlphaFold 1 and then AlphaFold 2. So can you give me a view of what it was like being at that really cutting edge of computational bio, and how do you see AlphaFold 2 influencing the broader ecosystem? And I guess also, what implications does it have for startups in the biotech space? Because it is very far reaching, and clearly, moving from DeepMind into building your own business with Latent Labs is clearly an indication of that. So yeah, we'd really love to understand kind of the whole experience and where you think that science and technology is going, and how how it influences the biotech space.
Yeah, very happy to speak about that. Really loved my time at DeepMind. It was a fantastic experience working on AlphaFold 2. Like you said, I did join when it was still AlphaFold 1, but at its tail end. So the team was really already writing up, the Nature paper for AlphaFold 1 when I joined, and that gave me time to ramp up in the domain. I'm not a biologist by training, I'm a physicist, and so it was really good to have that time and sort of shoulder rubbing with the team as they were finishing the work on AlphaFold 1. And I think there was already fantastic excitement around that model. It performed really well in the CASP, which is this structure prediction assessment competition at the time, and clearly you could see momentum building, but it wasn't sort of nearly at a level where an experimentalist, a biologist, would sort of drop things to use the model. So I think it's fair to say that there was good excitement also in the community, but it wasn't a game changer yet. And also internally, I think that's maybe how it projected. I would argue it was a great success, but it wasn't sort of like everyone was going to flock around that as a problem. And
hadn't yet proven out the transformational potential, I guess.
That's right. And so at the end of the day, when we started working on AlphaFold 2 then, we're still a small team, sort of maybe order of 10 people-ish, maybe a few more. And I think in hindsight, what I think is a remarkable thing that the team did under the leadership of John Jumper, who, of course, alongside Demis Hassabis, was awarded the Nobel Prize of Chemistry for the work. I think the remarkable thing that was done was sort of to essentially start from scratch. Like a lot of the ideas were dropped entirely, and sort of really, I think that took confidence, I think, to take a model that was sort of best in class, AlphaFold 1, and basically put it to the side and start again, essentially, with new ideas.
So like truly the scientific method. Let's start from scratch and test again. Yeah.
Yes. Yeah, exactly. And so, that I think in and of itself was a remarkable thing to do. And then, it's been talked about on other occasions quite a bit, but I think a few things came together in this particular area, including, a really good data set, testament to the community that built that over literally many decades. That we were able to build on top of. Then, there are great metrics to actually measure progress with, which, that's not always a given in the scientific domain, but here it was very clear, right? Like if we ascended this particular metric, we're looking at real progress. So that together was extremely valuable. And then it also coincided with, I think a whole bunch of innovations and breakthroughs that the team came up with during that time. Sometimes we joked, we could probably write up any of these ideas into a significant, research paper. But in the end, 10 or 15 of these were bundled up in this one Nature paper and, of course, the model itself. And so it was a sort of string of breakthroughs, and we really worked in a leaderboard-driven approach that gave us our North Star, and also the in some ways the right amount of, how do I put that, the right amount of excitement and pressure to beat that benchmark. Yeah, and it was all very collaborative, and at the same time that it was we gotta get that leaderboard up to that 90 GDT benchmark number, which is this metric we were after.
And out of interest, was there substantial kind of competition? I mean, clearly there was, because there were literal competitions. But I mean, who was the kind of closest competitor, if I can put it that way, in this space? Like who was building something similar? And did you feel that they were chomping on your heels, or were you just sort of focused on what you were doing internally?
Yeah, the interesting thing about CASP, this competition that we're speaking about, is it's held every 2 years, and that gives you quite a bit of time, and also others, to sort of keep developing your methods. And until then, there's no, or at least not much, open benchmarking that you could judge from how others are doing. So there's definitely, for instance, the lab by David Baker in Washington that was also heavily sort of involved in these competitions, always entered these competitions at a high level. There's a couple of competitors that often performed well. And then, with sort of the general advances being made in deep learning, it was sort of reasonable to assume that other tech companies, other startups would enter the game. And that did happen. It just ended up in a way where, the AlphaFold 2 model still, by a significant margin, outperformed everyone else, but we didn't know that. So it was very it was very exciting when internally we saw that we hit our internal target benchmark numbers, but that still you never know, right, until you know whether it really does translate when it comes to the external benchmark, and how well others would be doing. Sort of from a timeline perspective as well, maybe that's going slightly too in depth too early, but the way CASP works is you essentially submit every week over a course of weeks. So it's like this ongoing competition for, I think, literally 2 or 3 months. And our very first submissions weren't that great. We knew that because they, as the competition keeps moving, they release the earlier targets so we could sort of see ourselves for how well we did. And the very first one was, I think, in hindsight, our worst. But that sort of, when we received that, we're like, that's not quite at the benchmark we had internally. What's going on there? But then from there, obviously, it performed really strongly, and so all taken together, it was this sort of very big advance.
Yeah. And so how do you anticipate it's going to sort of change the world of molecular biology? I mean, like what is the real world impact? Because I guess, for someone like me, I have some understanding, but I'm definitely not a scientist. I'm definitely not a biologist. I'm definitely not a chemist. And I think for the wider population, right, they may have heard of DeepMind possibly, and, arguably many won't have. But so what is the real world impact? Like what is this hopefully going to lead to, I guess, in terms of broader science and application?
Yeah, I think there are probably like at least two answers to this. So one is the very concretely this model. What does it do? And there basically AlphaFold solved single chain protein structure prediction. That means if you want to determine the sequence of a protein, the structure thereof, then you can now, with very high confidence, rely on an AlphaFold prediction, and in principle can sort of forego the experimental step that normally would have taken a long time to arrive at that crystal structure. There's caveats to all of that, right? There's little asterisks. There's certain proteins it might not do as well on certain sort of there's asterisks, but in principle, that statement's right, and that's a big deal. That's a big breakthrough. That's also why, of course, the Nobel Prize was awarded. It means that you can do that research so much faster. You can, in practical terms, determine, for instance, the structure of drug targets so much faster. And in the context of the company that I'm now building, Latent Labs, everyone we're speaking with is using AlphaFold too, and variants. So you really see that impact today. It's like used so widely across the industry and academia. It's the standard model that everyone uses, whether that's for structure prediction or also for sort of assessing protein designs, which is relevant to what we're doing. So one of the features that people really like is the uncertainty predictions of the model. And that's actually something that I've contributed to heavily. I've come up with this particular metric and prediction that the model comes with called PLDDT, and it turns out it's well calibrated. It can be used to, for instance, judge in a way how likely a designed protein is to work in the lab. And so in all these ways, AlphaFold has tangible impact today. But that's sort of what's AlphaFold doing today. I think zooming out, it's sort of perhaps one of the first examples where machine learning really has huge impact in the sciences. And I think it's going to be one of many.
This concept of computational biology, right?
Yes. Yeah. And I think it's an example of many more that we'll see, where what was sort of difficult to maybe capture with the language of math now becomes modelable by learning from data. I think we're gonna see more examples of that, and that's also what we do at Latent Labs. We want to move the process of drug discovery and more broadly design of biological systems into the computational realm. Where, with models like AlphaFold 2 and with models like the ones we're building internally for protein design, that is in close reach. Where, what that stands to do is replace the experimental processes that currently underpin drug discovery, where, it's usually an iterative process.
So this is in silico instead.
Right. Exactly. It's usually iterative. It involves, literally things like harvesting llama blood serum to arrive at nanobodies, or using hybridoma technology, which is a fancy word for sort of mice models, and all these sort of experimental steps where if you stand to compress that, and not only compress that but arrive at better solutions that you can't find with that sort of almost random search in the lab, then that's the big gain that we're looking at, because it's to be proven, to be entirely frank. But, when you think about the drug discovery pipeline, famously, it's 10 to 15 years. Maybe the first third is this discovery and optimization process for the molecule itself. But then the last 2/3 are basically proving that this drug is works.
Yeah.
And
Efficacious. Yeah, I could. we'll come back to that. We'll figure it out later. Yeah.
Exactly. Works in the human body and is safe in the human body. And that's where these clinical trials come into play.
Yes.
But
and to add to that, at huge cost, right? Like each drug takes up to $2 billion to develop and may not ever make it to market.
Yeah, that's right. And, part of that is the large failure rate of these clinical trials, where they're expensive in the first place, but then you have to sort of map the failed ones back onto the wins. And that's what makes drugs so expensive in a first order approximation. And basically what I'm trying to get across is the failures in the clinical stages, they can be related back to the molecule that you started with not being good enough, not being optimized and optimal enough. And that's the big promise. Like if you arrive at a molecule that is so good that you can sort of significantly increase the success rate in the clinical trials, you can make the whole process, at least the first third, significantly faster, and where maybe you unlock drug targets that were previously undruggable, or you come up with new form factors of drugs that were previously, that maybe not in nature's repertoire, then that's sort of the collection of promises in this area, which we're super excited about.
Yeah, and unsurprisingly so. I want to talk a little bit about Latent Labs as well, because it must have been a massive jump, right, to move from the stability of a company like DeepMind to launching Latent Labs itself. So I'd love to understand more about not only that decision, like how you came to it, but also how Latent Labs really aims to revolutionize this process of protein design, which you've described already a little bit, as well as the impact you see this having on R&D processes, again, as you've described, but also, how does one build a team of this significance, right? And is there a reason that the UK and maybe Europe more broadly has such an edge in this sort of space, which it certainly feels like it does at the moment?
Yeah. So in terms of, let me see where I start. Probably a couple of points to mention. So in terms of, why did I want to build Latent Labs? So as I mentioned, after working on AlphaFold 2, I started a protein design project within DeepMind, and that grew to its own team that I ended up co-leading. I also helped set up the wet lab that DeepMind now has at the Francis Crick Institute in London, and led that team for 2 years, and became absolutely convinced that this general area, generative modeling on proteins, was the way forward in this area. What I did see was that with the creation of isomorphic labs, basically building a drug discovery company on top of AlphaFold 2, that they were going after a lot of avenues at once. And I felt quite strongly that, with a focused push in this area, you could have tremendous impact. And it wasn't that clear to me how that would play out at DeepMind and isomorphic labs. And with my strong conviction around protein design in particular, I felt that over time, it was actually likely the better move to create a nimble team with laser focus in that area. And that was what led to, the creation of Latent Labs. And we built a really fantastic team. So we have a team in London and a team in San Francisco. In London, currently, we're building the frontier models themselves. So we're doing the machine learning research. We're joined by others from DeepMind. So someone who worked on all 3 versions of AlphaFold, for instance, have joined. Someone I worked with, of course, in the past. So that's been fantastic. Our head of operations, she was at DeepMind for 8 years and, led different programs in the science team as a program manager, the genomics team, biologics team as well, and the quantum chemistry team there. So has that fantastic experience. Then we have someone as part of the team who actually did start the science team itself at DeepMind. So
Amazing.
that's incredibly valuable steering that we get from them, and fantastic to work with them. And so really strong team together.
And could I just ask, I mean, was there resentment from Google stroke DeepMind that you'd pulled the team out, or is there support? Because presumably, and especially in kind of scientific endeavors, science is you are standing on the shoulders of those that came before anyway, right? So presumably, actually, for DeepMind, this is a success story because as a result of what you and essentially they had built within Google DeepMind, you found another avenue that built upon the work that you'd already done. Is there a sense of success for everybody, or was there a little bit of it's a shame these guys are leaving, they could have done it internally?
No, I think so. I think people are very happy. We had extremely good responses as part of our launch just a little over a week ago. People really celebrating with us. We're also just generally still friendly. We joined the team in Stockholm for the Nobel Prize ceremony, and we all get along well and are friends. So. I think that's very much the case.
Yeah. And kind of going back to my earlier point. So, in terms of, I guess, that deep research and academic rigor, do you see Europe as being still at the forefront of it? Because one of the conversations that I certainly have on this podcast a lot is, there is a bit of a talent drain, maybe from individual countries as opposed to necessarily Europe as a whole. So, Italy, for example, has very, very strong, deep academic traditions. But if you go to Italy itself, there's very little being done in terms of commercialization of some of the outcomes from those, whether it's university programs or research programs elsewhere. So they then tend to move to, say, the UK or the US or elsewhere. So do you think that Europe is still sort of at the forefront of these sort of techniques and modalities? And I guess especially given kind of where we're seeing the trajectory of the US at the moment and uncertainty over a number of things, if I can put it mildly, do you think that Europe and the UK especially, I guess, has a much stronger role to play in these sort of scientific endeavors? Or do you think that may shift over time?
No, I do think Europe and the UK are, scientific powerhouses. I think that's definitely true for the sort of hard natural sciences and beyond, right? But I guess that's what we're talking about. I think where maybe, in my humble opinion, we probably need to do a bit more is sort of the translation piece. And with sort of AI, obviously, that's what we're at the end of the day as a context speaking about. With AI, it is obvious that you need more resources to actually build these models, execute on the research that's required for AI for science. Where perhaps if one's not careful, academia will have a hard time sort of doing that on their own. Yeah. So I think
you need both the sort of commercial as well as the academic collaboration for that to happen, right?
I think so. So I think it's in some ways a funding question, availability of.
We'll talk about that.
Yes. So I think the brains are there, the science is there. It's there are fantastic institutions around. All of that's also why we're in London and the UK too, sure. Right? Like there obviously are these fantastic academic institutes that still and very much produce an incredible strength of PhD students graduating from there with sort of a wealth of knowledge and people that we're lucky to have been able to recruit already as well. We've recruited from Cambridge, Oxford, PhDs in generative modeling and also in the bio side of things. So that's very much why we're here. And I think it's something to continue to be invested in. And I think maybe there's more to be done, but it's definitely strong.
So we have a foothold, and it's up to us, I guess, not to abrogate our responsibility or our ability, and ensure that we hold up sort of those strong, deep, roots that we have in terms of scientific discovery and development. And I guess one further question maybe on Latent Labs, just before we move on. You mentioned earlier that part of what you are building is about, allowing for for better and faster drug discovery, if I can really simplify it, right? But presumably you're not doing the drug discovery yourself. So is your model to then work with and partner with lots of pharma companies or asset developers? I mean, how do you see that playing out? What are you kind of crucially going to be doing, to ensure, I guess, that the technology has the biggest and widest impact possible across medicine and beyond?
Yeah, absolutely. No, great question. I think what we're seeing is there are, a couple of thousand, let's say, pharma, life science, and biotech companies working at the cutting edge. And there's a real distribution of sort of abilities across them. Some of them will be and are building internal teams, and many others, might not be able to attract that talent or want to even stand up in the first place an internal function around it. And so we want these companies to think about us as one of the best teams in this space with the best technology in that space that they can just instantly partner with. So why even, try to stand up your own function if you can work with us and have sort of an enterprise solution at the push of a button that you can, work with. And so that's the opportunity that we see, and that's how we would like to be perceived. And we think that, broadly leads to two main channels. So one is a platform, a self-service platform where people can directly access our models that plugs in well with their existing workflows. And, that should be so scientist friendly that you don't even need to be a deep domain expert in ML. It's sort of tailored towards
almost low code ML for biology, essentially.
Yeah, exactly. And if you want to go deeper, you can do that as well. You can sort of expose the bare metal if you want to, but you can also stay at a layer above it.
Does that mean, sorry to interrupt, does that mean that not only for kind of, to your point, not only for scientists that are already sort of in the field, etc. I mean, like, does this have application therefore for students? Like, could don't know about graduate, high school level, but graduate level students, would they be able to use your models and your platform for learning purposes as much as anything else?
Yeah, we think that's a very exciting sort of population, if you will, as well.
Because
definitely.
that also, to your earlier point, that's how we build up the scientific expertise and bring the new generation of scientists, researchers, etc. into the world, right?
Yeah, absolutely. We think that's an exciting area, the academic area, for sure. Yeah. So there's the platform. Just to complete my thought from earlier, there's the platform angle, and then we do believe that there will be sort of frontier applications where you might have to either build a slightly bespoke model, whether that's through fine tuning or otherwise, or where maybe you're working on a problem that isn't benchmarked, so it's not part of the platform yet, and sort of at that sort of cutting edge that will require some development, some hands-on work, that sits better with a partnership. So we'll also have these type of engagements with life science and biotech companies. Yeah, no, look, makes a huge amount of sense. You touched on this earlier, but I think goes without saying, congratulations. You've just announced essentially a $50 million round led by Sofinova Partners and Radical Ventures. So as a deep technical founder, because you clearly are a deep technical founder, what are the key challenges and lessons that you've learned from raising funds in the bio space, right? And why is it important not to accept the first
offer that comes your way. And the data suggests that sort of in 22, 23, there was actually a fairly significant dip in funding towards life sciences. From what I can tell, that seems to have kind of corrected itself a little bit, and 24 and hopefully into 25 is looking much stronger. But yeah, I'd love to get your perspective, and for others in the bio space that are looking to raise at the moment, what are some of the things they should be thinking about?
Yeah, look, I mean, I'm a first-time founder on top of being a deeply technical founder. So, we've raised a seed round and we've now raised an A round. So really, you have to take it with the caveat that I've only ever done it twice.
Okay, yeah.
But so, what I think I learned is it's very important to stay very nimble, sort of how you present your idea. That's not to say, tell person A something else than person B.
But not to be dogmatic about what your narrative is.
Yeah, and sort of, the way you present an idea matters, right? That might, that's true in academia as well, but it can sometimes be lost, right? It sometimes feels like, that formula or that model is self-evident, but here you have to tell the story.
Yeah.
And so it's about how you find your audience where it can listen, basically. And so, quickly iterating and talking to a lot of people, I think, is what you need to do. That can feel maybe to a technical founder daunting at first. But it's essentially what I've done. I think some people gave me the advice early on, just talk to a handful of people and raise some funds and run. And that might work for some people, but I actually opted to speak to really a lot of VCs and other founders and people who work in that space. And I think that was very valuable because there's so much to learn, particularly as a first-time founder, right, around the different types of funding, and then even a level deeper, like the lingo used, which is very different from, coming from a place like DeepMind or academia. Like there's a lot to learn. Let's put it that way.
It's why you need a CFO like us. But just saying.
Yeah. So there's a lot there, right? And then beyond that, I think it's about also standing your ground and knowing what you're building will be worth. And we didn't accept, like you maybe hinted at, the very first check that came our way. That was exciting, right? We had a term sheet there, and we said no. And that initially again was like a daunting thing. It felt like, oh, if we say no now, will we get another one? Yeah. But I think, right, you have to
because there's a very clear asymmetry of power, right, within that sort of venture space. Founders are raising from investors hold the power to an extent, right? Like, and if you're a sexy startup, it's easier to attract more investors, or was in the past, certainly. But that asymmetry still exists, right? You are coming to them for something. Now, yes, you are selling equity in your business and there is a transaction that's happening, but ultimately you've got to convince them that is something that is worth them, investing in and taking that risk, right?
Yeah, definitely. I think you have to sort of have some conviction around, what will be the trajectory as well, and sort of what is okay. What are the means that you need, and how often are you maybe going to go to the market again, if you will, and sort of mapping that out very early on. That might feel sort of strange if you're sort of at day zero, but I think it's worth doing and necessary. And the more you can back yourself up with well thought out sort of narratives and research that you've done and seen, I think the easier that is as well. So being firm in your mind too, I think what you actually really need and want will also help to say no to the thing that just doesn't match that.
Yeah, and just digging into that a little bit further, right? So you talked about it in terms of nimbleness, agility around your narrative, right? Now, I've come across founders that will take that one step too far. So for example, every single investor or customer or whoever that they speak, or reference client potentially that they speak to, who gives a suggestion, that then finds its way into the pitch deck. And all of a sudden you have this Frankenstein of, well, we started off doing this, but actually now we're going to kind of go in this very convoluted area. So I guess my thought and maybe a question is, that nimbleness, to your point, is important, but the focus should still be on what ultimately you're looking to achieve, right? Because what you don't want to do is, go out and say, we're building a computational biology business of whatever nature it is. And, just obviously using Latent Labs as the example. But then that then suddenly Frankenstein said, well, we're also going to be a platform. We're also going to be we're also going to develop assets. We're also going to do this, because I think what happens, and, this is the nature of the beast, is that investors then get confused and they don't see that clarity of thought that suggests that you are very hyper-focused on solving a problem and potentially are still not yet, investable, because effectively you haven't quite understood the problem solution sort of set. Would that be fair, or do you think that is in itself an evolution of kind of how you think about building, in your instance, Latent Labs, but more generally building a business, that if the market says, well, no, you don't want to be doing this, you should be doing 20 degrees to the right of that. Is that something that you would take on board as a founder, or do you sort of stick to your knitting and maintain your conviction around the principle and first idea?
Yeah, it's a great question. And, as you will be aware, asking the question, I think, it's very hard to generalize that. I do think both, in a weird way, sounds like I'm sidestepping the question, but I think both can be true. Yeah. I think there will be instances where it's very important to just stick to your conviction. If that's the case, I think you have to have a lot of evidence that your contrarian view is right, and you just stick with it. But in many instances, I think listening to someone who's done it before can be helpful. I mean, in general, what I've found is, nimbleness shouldn't mean indecisiveness. Yeah. Because you're gonna have to make a lot of decisions very quickly. It's one thing I've learned, and if you sort of make them too slowly or are too indecisive, and maybe even go around asking your entire network, you'll basically sample answers, and you'll sample the entire space. You'll get every possible answer.
You have an analysis paralysis.
Exactly. Yeah. And so I think it's good to surround yourself with a few trusted people. Of course, question that as well, like whatever their opinions are. But it's good to have a what's the word? Like have a mind ping pong with someone you trust really well, and then you can either go with what they're saying, or you can ignore them, but at least you feel like you've engaged deeply. And then I think you have to just have your own convictions.
Yeah, no, look, I'd completely agree with that. And I think your point is incredibly valid, right? So as a founder, what you should be doing is taking the pulse and understanding the temperature of, the thoughts of those around you. But ultimately, it is your decision and only your decision, right? So an advisor's role is always to advise. It is not to direct or to execute. So, you want to be able to take the data, parse it, understand what the pros and cons are, but then, still come out with your own decision at the other end. I've worked sadly with founders that are indecisive, have a bit of kind of imposter syndrome around whether or not, they're making the right decision, and therefore, have tended to take on too many people's advice. And again, to my earlier point, end up with sort of a bit of a Frankenstein of an outcome, because, there isn't coherence around sort of that decision-making process, and therefore there isn't coherence in the decision itself, right? So, but equally, and I think, to your point, when you're a first-time founder, who maybe hasn't come from, from a startup and seen the sort of entrepreneurial journey of another founder or whatever, it is important to understand how the market works, what are the financial instruments that are out there, what is a safe versus a convertible versus a priced round, all of these sort of things, because ultimately you also want to be able to walk into any negotiation or any fundraise knowing when to push back and what to push back on, and to be able to do that equally in the moment rather than having to go back each and every time and sort of then re-explore, right? So no, I think it's a fundamentally important skill to learn. And I would argue, actually, I mean, like, whether it's fundraising or negotiating commercial contracts or anything like that, right? Like, it is always better to come equipped with answers and know in which direction you want to go, rather than sort of having to, because again, from a asymmetry of power perspective, if it's kind of like, well, okay, well, he doesn't know what he's doing, I kind of smell blood, maybe there's an opportunity for me to I don't know, get the valuation down a bit, or include an additional liquidation preference or whatever, right? Like, there are many mechanisms, but kind of moving on from the fundraising question, because like, clearly that was you clearly were very successful and have some very good partners involved. And obviously, as you all know, we've had Ed from Sofinova on the podcast as well. But when we first spoke, you said it was very important not to lock yourself into one location. So I'd love to understand from your perspective how vital that geographic flexibility is for a startup, and how being based both in London and San Francisco has been beneficial for Latent Labs. Because ordinarily, I would always advise a founder, don't err on the side of less complexity rather than more complexity. And obviously, the minute you start opening up in new regions, etc., I mean, like, when you're well capitalized, it's one thing, but if you are, relatively early and still don't have necessarily a huge amount of capital behind you, trying to manage two locations, trying to build a team in two places, all of those sort of things can actually be quite difficult. So yeah, I'd love to understand kind of how you found it beneficial and what's worked for you.
Yeah, it's a great question. So maybe as a piece of context, came through a little bit earlier, but we have our London team that currently focuses on the building of the frontier model, so the ML R&D. And then in San Francisco, we have a wet lab, and we also have applied computational people, you could put it, people who are bioinformaticians and computational protein designers that use our models to make proteins that are then tested in the lab. Really, the decision was very much driven by access to talent, actually. So we found it was I wouldn't say easy, but it was obviously doable to build a really strong machine learning team here in London. And at the same time, we found a lot of the high throughput protein engineers and biologists and computational protein designers to be more on the perhaps west coast of the US. And at the same time, obviously there's a lot of ML talent there as well. Many people are, of course, part of big companies there too, or very well capitalized startups, so it's hard to get them. But in principle, you have a very deep talent pool there. And beyond that, London and San Francisco really are hotbeds at that intersection of biology and machine learning. And so the key driver was the talent, but then sort of maybe the second order thought as well was to be in spaces where the meal's currently cooked, and that is sort of a more soft advantage. But I do think I profit, and the company profits from that a lot. So whenever I'm in San Francisco, which is quite frequently these days, can there meet up with other founders, sort of take the temperature of what they're seeing and how they're working with partners, and it's just incredibly valuable to have access to that network there as well.
Yeah, it's that proximity point, right? It's proximity to talent, to thinking, to investors, and to companies, right, and potential partners, and. So to that point, right, like, you wouldn't go and build a business like this in Bora Bora because you're just not going to get, access to that. Now, that's obviously a very facetious comment, but there are very clearly, strong pockets for these sort of things. So you wouldn't necessarily consider going to New York, but you might consider going to Boston, right? For example, if you wanted to be adjacent to the kind of more traditional pharma kind of ecosystem. And what did you? I mean, so just talk me through the thought process when you actually decided to launch and build both in London and San Francisco. Was it a case of kind of starting in London and then realizing that there was this additional talent and skill set that was in San Francisco, or did you know from the start that, okay, I'm going to need to build in both locations in order to access that talent and proximity to to others?
Mm-hmm. I did think from the start that we were going to do that, but I did think that was going to come later.
Right.
So it came earlier. It became a question of interest earlier than I had anticipated. Mm-hmm. I thought, 2 years in or something, we might have a satellite. But then half a year in, it was like, oh, actually, we need that talent now, and we keep finding it over there. And then started to seriously engage with that thought. And actually, that was one of those, I would say, sort of very decisive questions for us as a super young company, where, coming back to your question around maybe how you make decisions and sort of how you take on board other people's opinions, where I did speak to a lot of people in my network, because I felt very strongly that, like you say, it could lead to a lot of additional complexity and felt like a big decision, and it was, and got a lot of different advice. But at the end of the day, in some ways listened to my gut, and sort of at the same time, though, made sure I had mechanisms thought through how it was going to work well.
What does success look like if we do this? And I guess one of the questions as a founder, you'll always like, do I have the bandwidth to do this, right?
Yeah. And there's sort of examples to pull from that are at best adjacent, but where you can see structurally the problem is the same. Like, if you think about how, an early Amazon had this sort of 2 pizza team sort of idea, where the teams sort of have these serviced interfaces with each other, but otherwise they sort of can operate autonomously, and they just sort of basically have an agreed handover point, and sort of equipped with that kind of success story, if you will. The sort of mapping that onto our problem means you keep sort of what the teams are working on functionally.
It's like an API handshake, right? Like essentially, you work autonomously, but you essentially then come together to.
Yeah. The entire point is to not block each other the entire time, especially across time zones. So for that to work is you need some handover, and you need to be functionally, at least disjoint to a good extent. Yeah.
No, I think, again, having experienced, teams across multiple locations, I mean, it can be incredibly challenging. Exactly to your point, probably the most challenging thing is the bottleneck issue, where, if you are waiting 6 hours for someone on the other side of the, of the hemisphere, or wherever it is, to provide you with a solution, or that that piece of knowledge or whatever it is that you're waiting for, it can be incredibly frustrating. And equally, I guess, within the bounds of that, because you're working essentially a hybrid, right? Because essentially by default, half your team is remote to the other half of the team, right? So how do you, from a cultural perspective, how do you kind of bring that all together and make sure that they are, all feeling like they are heading in the same direction? Or has that not been a challenge?
No, it's definitely something as well that going into it, I thought about quite a bit, and talked to founders who had the same thing. I talked to someone who ran a ML team in Berlin and lab in SF, and that felt like that's pretty much the same thing. So how are they getting
equivalent?
how are they doing it? We ended up doing a very similar thing to them, like just have frequent in-person offsites. So every quarter at the moment, at least, we have sort of 1 week offsite where we all come together, and that really helps to refocus everyone.
Is that always in one or the other of the location, or do you go to third locations?
We've done all three of them. So
Okay,
we've had it in London, we've had it in San Francisco, and actually in 2 or 3 weeks we're going to New York, where we're in the middle.
I mean, without being funny about this, and again, I take context from some of the things that I'm involved in. I actually think sometimes doing it outside of the core kind of office locations is actually quite useful for creativity and thinking, because you're not bound by the office and the emails or whatever might be happening, right? You have the space to kind of explore the potential of whatever you're doing without having the distraction, if I can put it that way, of being in the office environment. So but I obviously would agree that you still, because the other thing is you want to have the team understand what the other side of the team is doing, and that cross collaboration, right? And that if you are in the office in San Francisco or in London, it's going to be much easier. But yeah, I mean, I would definitely say that external locations can be incredibly helpful, and I think aren't taken advantage of enough. And it doesn't need to be an exotic location, but a decent one is always going to be helpful.
Yeah, no, that's exactly how we've done it in the past. Sort of, day one was at the respective office, so that the other team saw the context, and when there's new joiners, that's incredibly helpful to just even conceptualize how that other team might be working. And then we've always gone to a cabin in the wood type thing.
I mean, I can definitely suggest some cabins in Kenya if you're interested. Look, Simon, I mean, this has been a pretty incredible and wide-ranging conversation, but I just want to end up on one question, which I ask all of my guests, or have been for the last few months, with varied responses, I think it's fair to say. So what is one thing that you have a contrarian conviction about from any area of life, whether that's work, politics, socially, or at home? What is a hill that you would die on defending?
I think one that comes to mind is related to Latent Labs, where I think in the industry overall, it feels like an accepted wisdom that platform companies, especially computational platform companies, can't really work and scale and grow very much. And I think I disagree with that. I think we just haven't had the tools, and it's just not been the case that the systems that perhaps were put into platforms had the power and the impact that someone really had the large desire to work with them, and that pull was felt across the industry. And I think that's changing rapidly, and at least I think that's what's going to happen, and that's what we're building. And I think we will be able to build a fantastic platform company that will be desirable and impact and have that impact with our partners.
Yeah, the platform versus assets question is like, I don't know, it's a perennial bugbear with all the life sciences businesses that we come in contact with. Look, Simon, this has been a really wonderful discussion. For our audience, where can they find you online? Are you on LinkedIn, Twitter? Where's the best place for them to find you on the internet?
Yeah, LinkedIn, Blue Sky these days,
Okay.
Twitter.
You've gone the European way, yeah, sure.
Yeah, and then, of course, our website, latentlabs.com.
Okay, amazing. Well, look, thank you so much for joining me. It's been an absolute pleasure.
Likewise, really enjoyed the conversation. Thank you, Aarish.